Hello everyone, myself Pratiksha at C. Today I'm going to explain NoSQL in database management system. Coming to introduction to NoSQL, it stands for not only SQL, which means it does not include SQL in it. It is used to handle large volumes of unstructured, semi-structured or rapidly changing data. So here NoSQL is totally different from SQL, wherein in SQL they will store the database in the tables, or it will be in an ordered way. But here in NoSQL, the data will be stored in an unstructured manner, which will not be arranged, or it will not be in order manner. Coming to why NoSQL over SQL. So usually for fixed schemas and all we use RDBMS, but in modern web pages for scalability, flexibility and performance, they use NoSQL since it stores a large volumes of data and it has certain characteristics like scalability, flexibility, high performance and distributed architecture, which we will discuss in upcoming slides. Coming to history of NoSQL. So usually the RDBMS, that is nothing but relational database model, was introduced by Edgar F. Cole at IBM in 1970s, and this included like Oracle, MySQL and Microsoft Server, which dominated the database world. Later started the database like NoSQL, which was unstructured and used capped theorems and ACID transactions, and it is also part of a query language. Coming to characteristics of NoSQL, first thing is before scalability, we have to know that it is high level language and also non-procedural language. And it is also flexible schema. Flexible schema means the NoSQL databases don't require a fixed table structure. Coming to scalability, it is very scalable in nature, which means that in NoSQL systems, horizontal scalability will be generally used. Here, the distributed system is expanded by adding more and more nodes for the data storage. So vertical scalability, on the other hand, if you ask what it may differ from the horizontal scalability, like vertical scalability is nothing but it will expand the storage and computing power of the existing node. So in SQL systems, we usually use horizontal scalability. Next one, coming to availability, replication, and eventual consistency. Most of the applications in NoSQL system require continuous system availability. To accomplish this, what we will do is data will be replicated. That is nothing but divided over two or more nodes. So here each node will contain the replication of the data in the nodes in a transparent manner. So this replication will improve the data availability and will also improve reading performance, because read requests can often be serviced from any replicated data node. So since it gets replicated, so the read option can be used to read the data from each nodes. Coming to replication models. So as I said, it also uses a replication model. So replication model, two of replication model. So one of it is master slave replication, which requires only one copy to be master copy, and all write operation must be applied to the master copy and will be propagated to the slave copies, usually using eventual consistency. Next comes the master-master replication, which allows read and write at any of the replicas, but may not guarantee that reads at nodes that store different copies see the same values. Coming to the sharding of files, in many NoSQL applications, we will see sharding, which is also known as horizontal partitioning. That is dividing the files or horizontally of the file records, and it is employed in NoSQL systems. Where this will serve to distribute the load of accessing the file records to multiple nodes. Coming to high performance data access. So in NoSQL application, it is necessary to find individual records or objects from among the millions of data records or objects in a file. So to achieve this, what we will do is most of the system will use one of two techniques. It's hashing or range partitioning. So in hashing, they will use hash functions, and in range partitioning, the location will be determined by the range of key values. So these are all the characteristics of NoSQL. Coming to the categories of NoSQL. Document-based NoSQL, NoSQL key value stores, column-based or wide column NoSQL system, graph-based NoSQL systems, hybrid NoSQL system, and XML databases. So document-based NoSQL system. So it stores data as documents, typically in JSON or BSON, or it may be in an SQL for XML format. So each document is self-contained and can have a unique structure. For example, you can take MongoDB or CouchDB. Coming to NoSQL key value stores, it stores data as a key value pairs like a dictionary, where we can see the key values representing the pairs of many words. Simple and very fast for lookups using the key. Examples: Redis, Amazon DynamoDB, etc. Coming to column-based or wide column NoSQL systems, it organizes the data into columns instead of rows. So each row doesn't have any same columns, good for sparse data. And example are Apache Cassandra and HBase. Graph-based NoSQL system. It is designed to store and process relationships between data. Nodes represent entities and edges will represent relationship in this. It is perfect for social network, recommendation engines, and fraud detection. And examples are Neo4j, Amazon Neptune. Coming to hybrid NoSQL system, it combines the features from multiple NoSQL models. Example, document will be stored along with the key values, and it also offers flexibility and support for different use cases within a single system. Example are ArangoDB, object databases. So object databases will store data in the forms of objects similar to how they are used in object-oriented programming. It helps developers to work with data using same models as their application code. Example, you can take ObjectDB. The last one is XML database, which is specialized in storing and querying XML documents. So support is given by XPath or XQuery. Examples are BaseX and EXistDB. Going to the next slide. The CAP theorem. So the CAP theorem can be used to explain some of the competing requirements in a distributed systems with replication. Here the CAP stands for consistency, availability, and partition tolerance. What does all these three mean? Availability, of course, it means that each read and write request for data item will either be processed successfully or it will receive a message that operation is not completed if it is not successful. Partition tolerance means that a system can continue operating in a network connecting the nodes has a fault in two or more partitions. So there can be fault in any of the partition. It can be two or more than two. Consistency means the nodes will have the same copies of the replicated item visible for various transactions. So in ACID, here both in ACID and CAF we have consistency, but they have different meaning. In ACID, consistency refers to the fact that the transaction will not violate any integrity constraints that we have used in it and specified on the database schema. This is a cat theory. So this it is not possible to guarantee that all three of the desirable properties like consistency, availability, and partition tolerance at the same time in a distributed system with a data replication. Going to the next topic. MongoDB data model. So MongoDB is a type of NoSQL program. So it is a document-oriented NoSQL database which was developed by MongoDB Inc., which was first released in 2009, and it has most of the dynamic schemas, and it is more flexible and uses the documents called JSON-like documents called BSON, which is nothing but binary JSON. So it is documents-based storage, schema-less, horizontal scalability, powerful query language, high performance, cross platform, and open source. So here document based storage means like all the tables and rows or whatever it means are collected in the form of documents, and schema less means like it is semi structured or unstructured. Horizontal scalability, as I said before, it is more scalable and powerful query language, indexing, aggregation, text search, and you can also do geospatial queries. High performance, so it is optimized for read or write speed. Like its speed is too fast, and for real-time applications it can be used. Cross platform and open source, so it can run on cross platform. It is nothing but it can run on any operating system like Linux, Windows, and cloud platforms. Next, coming to the CRUD operations. So CRUD operation stands for create, run, update, delete. So first one is create, that is nothing but insert. So it adds a new document to the user's collection. So in the example as they have given here, so here Alice is the name and age 25 will be inserted. Coming to find, or nothing but read. So here the purpose is it retrieves the document from the collection. Like for example, here GT stands for greater than. Okay, explanation is that it finds all the users whose age is greater than 20. Update, it updates a document and find like here it finds the user named Alice and sets her age to 26. Okay, set, like dollar symbol with set is used to modify specific fields. Delete is used to delete a document. Like for example, here in the example given, it removes the username with Alice from the collection. Going to the next slide. Here are the difference between the MongoDB and NoSQL. So definitions are almost same. That document oriented. Here it is non-relational database. The type is that it will MongoDB will store in the document store, and it here in NoSQL it will include document key value also, column graph. Query language used here is MongoDB query language, like JSON-like, and here it varies according to it. Data format is BSON and it depends upon, whereas NoSQL depends on the type like JSON, key value, pairs, tables, graphs. Schema, it is schema-less, but it is mostly schema-less. Like MongoDB is schemaless, which is nothing but flexible, whereas it is here it varies by type. Use case, it is used for general purpose apps, and whereas NoSQL is widely used in caching, analytics, and social graphs. Joins not natively supported, whereas NoSQL depends on the database. Scalability here, as I said, MongoDB uses horizontal scalability via sharding, and NoSQL database support horizontal scaling. So open source, yes, MongoDB is open source, but NoSQL it depends upon some are open source and some are proprietary, as they have said. And MongoDB was developed by MongoDB Inc. and NoSQL is category. It is not a company. Cloud version is MongoDB Atlas, whereas in NoSQL some have managed cloud versions like DynamoDB, Redis Enterprise. Now after MongoDB we are going to learn about Redis, which is a key value store type. So here it stores the data in RAM. It is best used for caching, session storage, and real-time leaderboards. Some of the key features are they are extremely fast, like entire memory RAM will operate here, and it supports multiple data structures like strings, hashes, lists, sets, etc. Pub and sub messaging, it will support publish subscribe messaging model, and it is persistent storage options. So here are some of the key features: extremely fast, support data structures like strings, hashes, persistent storage, etc. Coming to Cassandra, which uses a column store. So it is wide column store where the data is stored in rows and columns. But unlike relational database, columns can vary by row, making it highly flexible. It is best used for high write throughout applications, time series data, and IoT. Some of the key features are they are highly scalable and fault tolerant. Peer to distributed architecture, that is no single point of failure is seen, used by top companies including Netflix, Instagram, and high availability and fast writes. And query language, Cassandra query language is similar to SQL but is tailored for Cassandra architecture. Last is Neo4j, which includes the graph database. Graph-based NoSQL database is used. It stores the data in the form of nodes and relationships. That means entities and edges rather than the traditional tables. It is best for social networks, example friends, followers like that, and recommendation engines and fraud detection. Some of the key features are data stored as nodes and relationship, as I already said, and supports cipher query language, a declarative graph query language which is similar to SQL, but it is optimized for querying relationship. Optimized for connected data and graph traversal, it is ideal for scenarios requiring complex multi-level relationship. Also, you can see the fast traversal through connections, which is difficult in traditional databases. Thank you.